Imagine staring up at the night sky, where every star represents a beacon of possibility. Now strip that sky of nearly everything. No stars, no galaxies, just an overwhelming emptiness. This is the KBC void, a cosmic desert stretching across 2 billion light-years. It's not just an absence of light, it's a profound mystery that defies everything we thought we knew about the universe. What if this vast empty region isn't just an anomaly but a clue, a key to understanding why we've yet to find any signs of intelligent life, why the universe's expansion doesn't add up, or even why our existence feels so isolated? This is more than just a discovery, it's a challenge to the very laws of cosmology. Could the KBC void be hiding the answers to questions humanity has been asking for centuries? The discovery of the KBC void didn't happen overnight. It began with astronomers mapping the distribution of galaxies using a technique called galaxy redshift surveys. These surveys measure how light from distant galaxies stretches as the universe expands. When they compiled the data, they found something extraordinary, a massive region spanning 2 billion light-years, nearly devoid of galaxies. To put this into perspective, this void is so vast that it would take light, the fastest thing in the universe, over 2 billion years to cross it. Initially, many scientists were skeptical. The standard model of cosmology, which assumes the universe is relatively uniform on large scales, seemed incompatible with such a void. It challenged the very foundation of what we believed about how matter is distributed across the cosmos. Yet repeated observations confirmed its existence, forcing researchers to reconsider their models. The KBC void isn't the first emptiness of its kind to be discovered. The Boötes void, for example, is another cosmic void, but at a mere 330 million light-years wide, it's dwarfed by the sheer scale of the KBC void. What makes the KBC void even more intriguing is its location. It's not far from where our own galaxy resides. This raises profound questions about how such an immense structure could form and what its existence means for our understanding of the universe. But the real mystery isn't just its size or location, it's the implications. Could this void explain why the universe appears to be expanding at conflicting rates? Could it be the reason we've yet to detect signals from intelligent life in the cosmos? The answers may lie within the boundaries, or the absence, of the KBC void. To truly understand the KBC void's significance, we need to explore its relationship with one of the biggest mysteries in cosmology, the Hubble tension. This phenomenon describes a puzzling discrepancy in how scientists measure the universe's expansion rate. The direct method involves observing nearby galaxies. By measuring the light from specific stars, like Cepheid variables and supernovae, astronomers calculate distances and the speed at which these galaxies are moving away from us. This gives a higher estimate for the Hubble constant, about 73 kilometers per second per megaparsec. The indirect method, however, focuses on the universe's oldest light, the cosmic microwave background, CMB. This afterglow of the Big Bang provides a snapshot of the early universe. By applying models of cosmic evolution, scientists predict a lower Hubble constant, around 67 kilometers per second per megaparsec. The gap between these measurements, known as the Hubble tension, raises questions about whether our understanding of the universe is incomplete. Here's where the KBC void comes in. Its size and relative emptiness create a localized gravitational anomaly. The void's lower density means less matter to slow down the expansion of space within it. Meanwhile, denser regions outside the void exert stronger gravitational forces, pulling galaxies outward and giving the illusion of faster local expansion. This difference could partially explain the higher values of the Hubble constant measured using the direct method. But what if the KBC void isn't unique? Recent simulations suggest there could be other massive voids yet to be discovered, each influencing local expansion rates. If true, these voids might collectively distort our measurements, leading to the observed discrepancies. This theory challenges our assumption that the universe is homogeneous on large scales, a cornerstone of modern cosmology. Moreover, alternative models like modified Newtonian dynamics, (MOND), propose that voids like the KBC form more readily in a universe governed by adjusted gravitational laws. Unlike the lambda CDM model, which relies on dark matter to explain cosmic structure, MOND suggests gravity behaves differently in low-density regions. If MOND is correct, it could reshape our understanding of both voids and the fundamental forces shaping the cosmos. So, is the KBC void an outlier, or is it part of a broader hidden pattern in the universe? Its very existence forces us to question the principles underpinning cosmology. Could it be the missing piece that bridges the Hubble tension, or does it hint at something even stranger? Why should we care about a vast empty region of space billions of light-years away? The KBC void might seem like an abstract concept, but its existence touches on some of the most profound questions about our place in the universe and even our future as a species. For the first time, the Hubble Space Telescope captured an image of the KBC void, a stark, haunting snapshot of the universe's emptiness. Instead of the usual vibrant clusters of stars and galaxies, the photo reveals a sparse, almost barren field of space, with only a few distant galaxies dotting the darkness. This image isn't just a photograph, it's evidence. It validates decades of theoretical research, showing that this immense void isn't just a mathematical concept. It's a real, physical region that challenges our understanding of how the universe evolved. What's even more startling is the contrast. Hubble's images of dense galaxy clusters, teeming with stars and activity, make the void's emptiness feel even more profound. It's as if we're staring into a cosmic abyss, a reminder of how unevenly the fabric of the universe is woven. So why does this matter? First, the KBC void reshapes how we think about intelligent life. If we are truly located in one of the most barren regions of the cosmos, it could explain the Fermi paradox, why we haven't found signs of other civilizations. Advanced life may thrive in denser regions of the universe, where resources such as stars and planets are more abundant. Meanwhile, the sparse conditions of the KBC void may create an evolutionary bottleneck, forcing civilizations to focus on survival rather than exploration or communication. Could this mean that Earth's technological advancements are a rare anomaly? Second, consider the practical implications for future space exploration. If humanity ever dreams of leaving the Milky Way, the KBC void represents an immense logistical challenge. The distances between galaxies within the void are so vast that intergalactic travel might require resources and technology far beyond what is currently conceivable. Even if signals from other civilizations exist, the void's sheer scale could make detecting or interpreting them nearly impossible due to delays or signal degradation. Third, the KBC void challenges fundamental cosmological principles, directly impacting our understanding of the universe. For example, if voids like the KBC influence local measurements of the universe's expansion, it means that our calculations of the universe's age, size, and future evolution might need to be re-evaluated. This could alter everything from models of dark energy to predictions about the ultimate fate of the cosmos. On a more personal level, the KBC void also challenges us to rethink how we view ourselves. If we are isolated in a cosmic desert, it highlights the fragility and uniqueness of human life. It serves as a reminder that even in the face of such vast emptiness, we have found ways to understand, explore, and question our universe. The void becomes a symbol not of insignificance but of humanity's capacity to seek meaning in the unknown. Ultimately, the KBC void matters because it invites us to ask, are we the exception or the rule? Is our position in the cosmos a random accident, or does it reflect something deeper about the nature of life and existence? The answers to these questions don't just expand our understanding of the universe, they redefine how we see ourselves within it. The discovery of the KBC void poses fundamental challenges to our understanding of the universe, and the stakes couldn't be higher. This isn't just about filling in gaps in our knowledge, it's about deciding between competing theories of how reality itself operates. The KBC void's existence strains the limits of our current cosmological model, lambda CDM, which relies on the concepts of dark matter and dark energy to explain the universe's structure and expansion. If the KBC void cannot be adequately explained by this model, it could point to flaws in one of the most successful frameworks of modern cosmology. In turn, modified Newtonian dynamics, MOND, a controversial alternative, suggests that gravity behaves differently at very low accelerations, eliminating the need for dark matter. The KBC void could provide the perfect testing ground for these competing theories. MOND predicts faster formation of cosmic structures like voids and could explain why such an immense region exists. However, embracing MOND would mean overturning decades of research and rethinking everything from galaxy formation to gravitational waves. What's at stake here is the foundation of physics as we know it. Are we ready to rewrite the rules of gravity? The implications extend far beyond academic debates. Understanding the KBC void could revolutionize how we explore space. If voids like this one are common, interstellar travel becomes even more daunting. Future missions may need to account for vast regions with minimal gravitational resources, where spacecraft could drift for millennia without reaching another star. Additionally, the gravitational anomalies of voids could distort measurements of celestial objects, complicating efforts to map the universe accurately. Ignoring these challenges risks misinterpreting our cosmic environment, potentially leading to technological missteps and wasted resources as we venture further into space. Beyond science and technology, the KBC void raises questions about our place in the universe. If voids are inhospitable to intelligent life, it could mean Earth is more of an outlier than we ever imagined, a lonely beacon in a sea of nothingness. This shifts the Fermi paradox from a hopeful search for neighbors to a sobering reminder of our isolation. At the same time, failing to address these questions risks stagnation. If we dismiss anomalies like the KBC void as irrelevant or too complex, we risk losing the curiosity that drives discovery. The void isn't just empty space, it's an opportunity to confront the unknown and push the boundaries of what we can know. The KBC void's discovery raises profound questions about the nature of the universe and the biases in our observations. Being embedded within such a vast low-density region may mean that many of our current measurements of the cosmos are unintentionally skewed. For example, the perceived faster local expansion of the universe could be an illusion created by the gravitational effects of surrounding denser regions pulling galaxies outward. This suggests that key cosmological parameters such as the Hubble constant or even the calculated age of the universe might be incomplete or context-dependent. If our position in the KBC void distorts these findings, it calls for a re-examination of what we think we know about the universe's structure and evolution. Beyond the scientific implications, the void challenges the perception of Earth's mediocrity in the cosmos. The anthropic principle, which posits that the universe appears fine-tuned for life because we exist to observe it, gains new relevance in this context. Could it be that living in such a barren and stable region of space was a prerequisite for life as we know it? In denser regions of the universe, abundant resources might accelerate technological development, but such regions also face frequent catastrophic events, like supernovae, which could stifle the evolution of life. The KBC void may paradoxically be the ideal environment, a cosmic balance where life can thrive long enough to reach complexity and intelligence. Speculatively, the KBC void could offer more than an isolated perspective. It might point to hidden dynamics shaping the cosmos. Emerging research suggests that voids like this might influence our understanding of dark energy, which drives the universe's acceleration. Studying the gravitational and material dynamics of voids could provide clues that refine or replace the current lambda-CDM model, leading to breakthroughs in explaining the forces governing the universe's expansion. Additionally, the concept of unseen networks, bridges of dark matter or other unknown forms of energy connecting galaxies and voids, hints at an underlying structure that we are only beginning to glimpse. The KBC void doesn't just challenge existing models. It forces us to confront the philosophical implications of our existence. Are we uniquely situated in a region that has allowed for the rise of intelligent life, or are there countless other voids housing civilizations just as isolated as ours? This tension between isolation and connectivity, between uniqueness and commonality, highlights how little we truly understand about the universe and how much there is left to discover. Exploring this void is more than a scientific endeavor, it's a step toward redefining our place in the cosmos. The KBC void is one of the cosmos's most baffling enigmas, raising questions about how such vast emptiness formed and what it might reveal about the universe. Advanced telescopes like the Nancy Roman Space Telescope will soon probe its depths, potentially uncovering hidden dark matter filaments or connections to the mysterious force of dark energy driving cosmic expansion. Traditional gravity models struggle to explain such voids, but emerging quantum gravity theories might reframe them as fundamental structures, not anomalies. Could the KBC void hold the key to understanding gravity at cosmic scales or even challenge our view of the universe's architecture? For future space exploration, the void presents a daunting obstacle. Crossing such immense, resource-scarce expanses would require revolutionary technologies, turning it into a test for any civilization aspiring to leave its galaxy. The real intrigue lies in what might still be hidden: faint signs of past cosmic interactions, undiscovered galactic remnants, or even isolated civilizations clinging to its edges. Each discovery brings us closer to answers or deeper into the mysteries of the void. The KBC void's emptiness creates significant obstacles for exploration and understanding. Vast distances and a lack of nearby stars render current propulsion systems and energy-dependent technologies ineffective. Revolutionary innovations like harnessing dark energy or creating fully self-sustaining habitats will be essential for navigating or colonizing such regions. Even advanced concepts like Dyson spheres become impractical in a void, pushing us to rethink energy systems. Additionally, the void distorts our understanding of the universe's expansion and dark energy, challenging existing cosmological models. Overcoming these hurdles could lead to breakthroughs in understanding gravity and the universe's structure, but also forces us to question the purpose of exploring such barren spaces. The KBC void challenges everything we think we know about the universe. Could it reveal that the laws of nature vary across the cosmos, or hold answers to the mysteries of dark energy and gravity? As we peer deeper into this vast emptiness, the possibilities grow. What secrets does the void hide, and are we ready to uncover them? Only time will tell.